Welcome to Marine Tech Talk, a podcast about how Teledyne Marine's innovative technologies are enabling scientific discoveries and commercial tasks in the world's oceans and waterways. In this episode, we will be speaking with Lou Nash, the president and founder of Measutronics Corporation. Measutronics is a marine positioning, guidance, and underwater imaging company that specializes in marine construction solutions, and first discovered the benefits of Teledyne BlueView's BV5000 scanning sonar in 2014. Lou leads the company in technology acquisition and systems integration, and he is also an adjunct professor teaching Marine Geomatics at the University of Florida. Now here's Lou Nash with the host of Marine Tech Talk, Melissa Rossi.
Lou, could you tell us a little bit about your company and where you're located, a little bit more?
Okay, so Magictronics is, we're a marine positioning, guidance, and underwater imaging system. A big part of our focus is in marine construction applications. Our main office is based in Lakeland, Florida. We've, in the last few years, started a second office in Vancouver, Washington. When
you and I were chatting previously, you had mentioned that you'd started doing some work with putting sonars, specifically I think one of the BlueView sonars, on construction barges. Can you tell me a little bit about that, how it all got started?
Yes, ma'am. That goes back quite a ways. That in 2014, I was starting to see some of the marketing, some of the literature out there from Teledyne BlueView on their BV5000 being used in a system configuration they referred to as motion scan. I looked at that and I thought about it and I thought, wow, with, the whole premise behind motion scan is that with a mechanical pan and tilt, it replaces the requirement to have the survey boat pass through a given area to insonify the bottom. I looked at that and thought, wow, if we can incorporate that on a construction barge, the contractor can get the value of that, the real-time updates on surfaces and such. So there was a Teledyne Reson users conference that fall in Boston, and I went up to attend the conference. And really my only mission in going there was to see what the BlueView guys had to say about their motion scan system. So I actually sat in the same session 3 times. I just changed my seats each time so the guy didn't catch on. But I was up there just doing my own, does this make sense? Sort of a, not really espionage, but wanting to know, is it really more than the spec sheet? So from there, we that was, I guess, kind of late October of 2014, and a follow-on to that was February of 2015, because of the Underwater Intervention Conference that I met with the BlueView guys at, we had an off-site meeting. Discussions with them, I wanted to kind of solidify what I'd seen in Boston and ask questions. And I think we learned from and of each other. The BlueView guys saw that we really are a part of the marine construction market and we understand it. We also understand sonars. And what I saw of them is that the product, they were in probably the earlier stages of development, but it did meet the requirements that we identified up to that point without having, really actively been in that type of application before. I saw they were committed to moving forward. They saw we were the right guys to go there. So we formed a relationship, and we took on BlueView dealership and bought some gear, and then started to figure out how to make it work. Our guys are real hands-on, and I've always been a big proponent. My business model from day one has been that we don't sell anything we don't own and operate. So we got the system in and put it in front of the guys and said, figure it out, and let's see how we're going to put it on a barge.
So let me ask you this question. What is the purpose of the sonar on the barge? What does it do?
The very nature of marine construction, so, there's a large machine on a barge, and it's placing or removing materials, something like that. As Trimble Marine dealers, we have the technology to give guidance of the tool. We can position and give guidance of the tool, be it excavator bucket, grapples, shears, jackhammers, clamshell buckets, what have you. So So we can position that very well, and we can track it underwater. We know where it's at relative to design, relative to grade. We only know where the tool has been. We don't know once the tool has passed through an existing surface, bottom, structure, whatever have you. You don't really know the condition of what you left behind. So a really easy analogy is, let's say the operator made a scoop with the bucket, so our guidance system would show that material has been removed, but maybe he was distracted. Maybe he flipped that bucket and dropped the material back in. Maybe the material sloughed back in or something, and we only know where the tool's been. We don't know the true existing conditions of the surface after he's passed through it with the tool. So the software gives us the ability to give a real-time update of that survey, of that surface, to give the machine operator the most current conditions.
So what were they doing before this sonar was available, or before they started using it on the barge? How were they determining what was left behind after the barge came through and did its work?
Yeah, so what they typically do is they work all week and wait for the surveyor to come on Friday. That's the big attraction of this. That's our big gain in productivity, is that we don't have to wait for the surveyor to tell us what happened. In the past, typically the surveyor identified areas that, hey, you have a high spot here, you have a low spot there, you have to go back and get it to make grade, because the surveyor represents the project owner's interest, and they want to make sure it's being built to spec. So what this does, by the contractor having that ability to create that same image in real time while the operator is there. Again, if there's high spots, he knocks them down. If there's low spots, he knocks them in. The whole idea, the premise being that on Friday, when the surveyor comes, there's no surprises. So you don't have to go back and rework anything.
So that's a huge time savings, I would think, on a construction project. You're not working all week, waiting for then a surveyor to come back in, find whether it was done correctly or whether things need to be fixed or changed, and then going back out again. You're able to actually do that more or less on the fly then as you're excavating.
That's right. And on the dirt side of construction, the bulldozer guys learned that lesson years ago, and there's a big analogy to where we're at in our technologies and the technologies that the bulldozers and other dirt moving machines have incorporated over the past 15 or so years. The bulldozers guys, as they started to put GPS on the blades of their dozers, the catchphrase kind of became only move dirt once. Push it to grade, and you don't have to go back. If you extract that out from pushing dirt with a bulldozer, getting it right the first time and only push it once, if you had to go back with a bulldozer, that's one machine, one operator. That's a waste. If the contractor has to go back with an excavator or a clamshell bucket or whatever the machine on the water, that's the machine, it's the operator, it's a barge, it may be a barge crew, and it's a tug crew, or maybe it's an anchor handling crew. It's more people.
Yeah,
so
it's a lot more people.
On the dirt side, everybody knows in construction, time is money. On the marine construction side, time is more money. And again, the very nature of it, they can't see underwater. Once that tool is below water, you don't know. I was
just going to bring that up because my husband's actually in construction, so I understand what it is when you move dirt here. At least you can visually see it above the ground, but underwater, that's not the case.
Yeah, once the tool goes underwater, you don't know.
Right. So this allows you to actually see that with a sonar, basically, what's been happening under the water, what it looks like, and whether the job's correct.
The sonar component, it truly gives us eyes underwater.
So where is this project at now? Are people actively using this technology? Is it just in its infancy, getting started? Where are we now?
I really feel we're just past the early adopters. We've got enough systems out there now, enough case studies, if you will, real projects, real contractors, real results, that we're just beginning to see it take off. I referred to the bulldozer issues maybe 15 years ago. 15 years ago, our company grew up in part of that business on the construction side, on the dirt side. One of the common things you would hear from contractors is, why would you put GPS on a bulldozer? And over time, they figured that out themselves. They know that only moving dirt once was more efficient. I really see us being in that same place now. We're still having contractors ask us, why would you put, a sonar on a construction barge? But now we do have enough reference cases through the life cycle of construction projects. We see them in the pre-construction phases. We have reference cases, the construction phase, what we call the as-building, and that they're seeing results as they build it. The marine contractor himself not having to rely on the results of the surveyor, at end of week or whatnot. And we even see it now in the post-construction phases, and that just monitoring and making sure structures are behaving as per design, let's say. So we see it following right along behind the same progression of the GPS on the bulldozers, and that, at one time the question was asked, why would you put GPS on a bulldozer? Now a real common statement is, how could you think of doing that project? How could you bid that project without machine control, without GPS on your bulldozers? We think the same thing will be, I feel strongly, that, sometime in the near future, it'll be the same situation with the sonars.
So really it has been a step change, or it's becoming a step change in the way people think about marine construction projects, and, how they're looking at the ground underneath, or the seabed underneath. And I think I remember you telling me that the change is not from an as-built state, but to an as-building state.
Right. So we've had to coin that term as-building, and again, that's just that the surveyor, the as-built survey, is still going to be a requirement of and by the owner to ensure that the project is built per specification. That they truly make grade, meet all the requirements of the project. But again, the immediacy of the marine contractor to be able to see the conditions, as they're building it. We've had to remind them that, no, you're not doing the as-built, you're doing the as-building. And I think that's somewhat indicative of how good the results are that we're getting from the barges. The technology is there.
And when you're talking about the technology, you're specifically referring to the Blueview sonar, the quality of the sonar that comes out of there, or just in general, the technology on the barges?
It's really a merging of all of that. The Teledyne Blueview is certainly, it's where we started. We did see some bumps along the way, going up the technology adoption curve. The Blueview is relatively high frequency at 1350 kilohertz, and high frequency, high resolution. The trade-off there, though, is somewhat lesser range than some of the other sonars. So we have seen on some real projects where that's a bit of a limiting factor. But being able to work with Teledyne, we've been able now to incorporate the T-Series, the T20, smaller, still real high resolution data. But at the 400 kilohertz frequency, we get, all the range we need for a construction project. And I think the contractors even like it in that it gives them more functionality, more options. So the sonars, all of that has been improved. There's more options as we work our way up the adoption curve. The software offerings now, Trimble has rebranded Teledyne PDS's software as Trimble Marine Construction. So now we've got Trimble's robust, rugged hardware solution interfacing with the machines via the Trimble Marine Construction software. And then because, the relationship, the PDS and Teledyne, it's real easy for us to bring in the sonar data in that real-time view, that real-time image for the machine operator.
So if we have a listener or listeners out there that are in the marine construction industry and they're interested in learning more or finding out about putting sonars or incorporating sonars on their barges, where do they go for more information? Well,
they're certainly welcome to contact us directly. Our website, Measutronics.com. We do quite a few webinars now. We incorporate a regular schedule of on-water demos, things like that. So there is a lot of benefit by in-person demos, seeing that it truly is happening in real time. It's not some guy in a dark room that's tweaking image files to come up with the slick marketing videos that we have.
Right.
I guess back in the day, I didn't trust the paper version in 2014, so I can understand that thought process with marine contractors now. But when we can get you there in front of the equipment, in front of our operators, it does come readily apparent that is truly a real-time 3D representation of the bottom, and there's no black magic happening behind the scenes in a post-process type application.
Great. Thank you very much. I appreciate your coming here today, Lou, and sharing your story with us.
Yes, ma'am. You're more than welcome. Thank you.
Thank you.
Thanks for listening to the Marine Tech Talk podcast. If you have any questions or comments about this show, you can email host Melissa Rossi at marinetechtalk@teledyne.com. If you like this podcast, please make sure to subscribe on Apple Podcasts or wherever you're hearing this show. That way, you'll never miss an episode. Thanks for listening, and we'll see you again next time.